So have you watched the lectures of the last class?
Yes, sir.
All right. So understood everything?
Yes, sir.
All right. Shikhani, what about you? Everything good?
Yes, sir.
All right. Kulsum?
Good, sir.
All right. Any doubts from the last class?
No, sir, no doubts.
No doubts. All right. So in today's class, we're going to solve a lot of questions, like which can be a difficult part of maxima minima. Okay. So in the last class also we did a question like that. The how much is the side of the square and so on. Hello, Ronaldo. Good evening. Any doubts from the last class, Ronaldo? No. All right. So let's start with the questions. Write down. Show that all the rectangles inscribed in a given fixed circle has the maximum circle. Square has the maximum area. Write it down, don't try to solve it. I'll explain how to solve this. Done, everyone?
Yes, sir.
All right. So in the question, what they are saying, there is a given circle. That means R is fixed. All right, R is not changing. Secondly, they are saying we can draw a lot of rectangles in this circle, different shapes, right? What are they saying? They are saying prove that the quadrilateral rectangle having the maximum area will be the square. And what is the difference between square and a rectangle? What is the difference between the square and the rectangle?
Squares have all sides same.
All sides same, right? So we have to prove that two sides are equal. All right. So this is a rectangle. I have drawn a rectangle here. How to solve this type of question? What is given to you? This R is fixed. Suppose this is A, this is B. Because this is rectangle as of now. We have not proved this is a square. All right. So this R is given. This is also R. All right. This will be the diameter. This angle is 90 degree. All right. Let's name this A, B, C, D. So who can tell me the area of ABCD?
A into B.
A into B. Right. So this should be maximum. Always write down the equation of the quantity that has to be maximized or minimized. So square has the maximum area. So I wrote down the area. All right. Suppose let's call this S. All right. So S is AB. We have to maximize this. And remember another thing, always try to put the equation in single variable. Right now we have two variables, a and b. So how to convert this in single variable? Find out any equation from the given information. So can anybody tell me how to like change a from b to a or a to b? Any equation you can think of?
So Pythagoras theorem.
Pythagoras theorem, absolutely right. So this is 90 degree. So we can write a square plus b square equals to 2r whole square. Right, everyone?
Yes, sir.
All right, Kulsum, Ronaldo, Shikani.
Yes, sir.
All right. So from here we can write a square plus b square equals to 4r square. So we can write a square equals to 4r square minus b square. So we can write a equals to 4r square minus b square to the power 1 by 2, right? Root we can write 1 by 2. So now replacing this value in equation 1, suppose this is equation 1, equation 2. So from equation 2, we can say s equals to a 4r square minus b square to the power half into b. Anybody has any doubts on this? Anybody, any doubts till now?
No, sir.
So here r is a constant and b is the variable, right? Because they have told you this circle is a given circle. That means this circle will not change. All right. So r is a constant. So to maximize, we have to differentiate this ds by dp. So how to differentiate this? We have to use product rule, this into this, right? So we can write b into differentiation of 4r square minus b square to the power half plus 4r square minus b square to the power half into differentiation of b. If anybody is not comfortable with a and b, you can take x and y also. No worries, same thing. So ds by dp equals to b into, what is the differentiation of this? We have to use chain rule. So this half comes outside into 4r square minus b square to the power half minus 1 into minus 2b. Right? Differentiation of this is minus 2b plus 4r square minus b square to the power half into 1. This thing is clear, everyone? Krishna, Ronaldo, Kulsum, Shikani?
Yes, sir.
All right. So now what we have to do, we have to put ds by dp equals to 0. Find the value of b. Let's simplify this. This 2 and 2 is cancelled. Right. Nothing else to simplify. So we can write minus 2b into 4r square minus b square to the power minus half plus 4r square minus b square to the power half equals to 0. Right? So this is minus 2b upon 4r square minus b square to the
Sir,
power
it's
half.
minus b square, right?
Sorry, yes, minus b square. Absolutely correct.
Sir, there's no 2.
There is no 2. I'm sorry. Equals to 0. All right. So you can take this to this side. So b upon 4r square minus b square to the power half equals to 4r square minus b square to the power half. Throw this to this side. So half and half, like under root multiplied, we get the same thing. Again, this is b square, my bad, equals to 4r square minus b square. Any doubts till now?
No, sir.
All right. So this b square will go to this side. So we'll get 2b square equals to 4r square. So b square equals to plus minus root 2r. But we have to, sorry, b is equals to plus minus root 2r. So we have to what? Can anybody tell me if we have to consider both the answer or single one?
So only positive one.
Why so?
So length can be positive one.
Yes. So we have to disregard. All right, negative one. Is everybody clear about this, or am I just speaking to myself? Everyone is clear?
Yes, sir.
All right. Hello, Ishan. We are solving in new questions. New question. All right. Let me just solve it completely. I'll show you again. All right.
Yes, sir.
So we got the value of b as root 2r. Now again, what we have to do? Find d square s upon dp square, right? To see if at b equals to root 2r, this thing is maximum or minimum. So we have to differentiate this thing again. This is the differentiation. So if we have to differentiate this, let me just rewrite the equation. ds by db equals to minus 2b square. Sorry, there is no 2. 4r square minus b square to the power minus half plus 4r square minus b square to the power half. So differentiating this again, we have to write this into differentiation of 4r square minus b square to the power minus half. Should I write in the new page, or this is readable, right, everyone?
Readable, sir.
Because it is going to be lengthy. Plus 4r square minus b square to the power minus half into differentiation of minus b square. This is differentiation of first part. Now differentiation of this also. 4r square minus b square to the power half. All right. So d square s upon db square equals to minus b square into differentiation of this is minus half into 4r square minus b square to the power minus 3 by 2 into minus 2b plus 4r square minus b square to the power minus half into this is minus 2b plus this is half into 4r square minus b square to the power minus half into minus 2b. This thing is clear, everyone? Simple
Yes, sir.
differentiation. All right. Kulsum, Shikhani, Ronaldo.
Yes, sir.
All right. Now we have to simplify this. Let's simplify this. See, in all the questions we are going to do today is going to be very, very, very lengthy. All right. And there is a high chance this type of question will come in the examination. So please, if you have any doubts in any step, just ask. All right. Simplifying this 2 and 2 is cancelled, minus minus plus, and we can take something common, but let's see first. This is minus b square into 4r square minus b square to the power minus 3 by 2 minus 2b into 4r square minus b square to the power minus half minus b 4r square minus b square to the power minus half. You can directly put the value of b is root 2r, no issues. So please put the value, tell me what you are getting. B is equals to root 2r. Put b equals to root 2r in this equation. Tell me what value you are getting.
So in the first term, I think it should be b cube, right?
Yes, this b is also there. So b cube, very good, Krishna. Yes. right? So if I like miss something, just tell me. All right, I have many wires going around in the screen, so all right, let's put the value of b equals to root 2r and see. You can take something common from this also. Done, everyone? So this is simply minus 3b into this. So minus b cube times 4r square minus b square to the power minus 3 by 2 minus 3b 4r square minus b square to the power minus half. Put the value of b equals to root 2r. So we get this is minus root 2r cube 4r square minus root 2r square. So we can write 2r square to the power minus 3 by 2 minus 3 into root 2r 4r square minus 2r square to the power minus half. All right. So this is, I can write 2 root 2r cube. This is 2r square to the power minus 3 by 2 minus 3 root 2r into 2r square to the power minus 1 by 2. Yes or no, everyone?
Yes, sir.
All right. So you can take the negative quantities in the denominator, 2 root 2r for simplification, or you can just multiply again, but let's do this. So this is 2r squared to the power 2 to the power 3 by 2 into r square to the power 3 by 2 minus 3 root 2r upon 2 to the power half into r square to the power half. So this thing is cancelled. Yes or no?
Yes.
All right. And this thing is also cancelled. R square root is r cube is cancelled. Yes or no?
Yes, sir.
All right. So we can see this is also 2 raised to the power 3 by 2. So this is also cancelled. So minus 1 minus root 2 is also cancelled. So minus 3. So minus 4 is the answer here. Yes or no?
Yes.
Is everyone clear what I did here? Because if 2 into root 2 to the power 3 by 2, just the powers, exponents and power, right? So this is t square s upon db square, which is less than 0, right? At b equals to root 2r, which is less than 0. So at b equals to root 2r, s is maximum. right? If double differentiation, double derivative is negative, that means the thing is maximum there. Kulsum, Krishna, Ronaldo, Shikani, Ishan.
Yes, sir.
All right. So this is the answer we got. B equals to root 2r. So just find the value of a. We got a square equals to. Can anybody tell me the equation? A square must be equals to 4r square minus b square. Right? A square plus b square, we got 4r square. So let's put the value of b square, 4r square minus 2r square, again 2r square. So a equals to root 2r. So we can see a equals to b. Hence, a rectangle is a square. Is everybody clear about this? Yes or no? What we did?
Yes, sir.
All right, Kulsum, this thing is clear?
Yes, sir.
All right. Shikhani, Ronaldo.
Yes, sir.
All right. See, these are very important questions. See, all these steps are similar, exactly same, but differentiation in this type of questions is a bit difficult. So please note it down, and you can see how long these questions can be. So please note it down. I'll give you some time. All right. Ishan, what we did, the question said, given that there is a circle and we can draw many rectangles in it, show that the square has maximum area. So we assumed a rectangle in it with side A and B. All right, so area would be AB. So we want to maximize area and we name that S. All right, so here we have two variables. So we can never differentiate with two variables. So trying to replace one variable with another. How? By using Pythagoras theorem in triangle ABD. All right. So from this triangle, we can write a square plus b square equals to 2r whole square. From this, we got a equals to 4r square minus b square to the power half. Now substitute the value here and differentiate. Rest of the steps is same. All right, Ishan?
Yes, sir.
All right, note it down.
So can you scroll down?
Give me a second, all right? Done, anyone? This is the first part. Then you can move on to this part. Done, everyone? Krishna, Gulsum, Ronaldo, Ishan, Shikani.
Done, sir.
All right. Everyone else? All right, Shikani. Ronaldo, Kulsum, Ishan. Just a minute. All right. Done, everyone?
Done, sir.
All right. So next question we have is, done till here, right? Till the solution.
Yes, sir.
Show that the right circular cylinder of given surface area and maximum volume is such that its height is equals to the diameter of the base. All right, note it down, don't try to solve it. I'll explain how to solve.
So what's after its height is?
Height is equals to the diameter of the base. Done, everyone?
Done, sir.
All right. So let's draw the diagram. What they are saying, prove that there can be many right circular cylinders. What they are saying, maximum volume, right, of a given surface area. Given surface area means S is constant. This will not change. All right. And maximum volume, that means we have to maximize volume, and the condition is automatically out as the result. No worries. So let's draw the diagram. This is R, this is H. All right. So who can tell me total surface area formula?
2 pi r into r plus h.
All right. So this is constant. What is the formula for volume?
Pi r square h.
All right. So now again we have two variables in volume, r square and h. So we have to find one variable in terms of other from this equation, rewrite in here. So we can easily find the value of h here. So we can write s equals to 2 pi r square plus 2 pi r h. So 2 pi r h equals to s minus 2 pi r square. So h equals to s minus 2 pi r square upon 2 pi r. This thing is clear?
Yes, sir.
So let's call this equation 3, this is equation 1, this is equation 2. So from equation 3, we can write equation 2 as volume equals to pi r square into h s minus 2 pi r square to 2 pi r. Right? Very simple. Now we have to just differentiate this. And differentiation, we have already championed in that. Pi is pi cancelled, r square is cancelled. So simplifying, we can write v is equals to 1 by 2. Let's multiply this r inside the bracket. So s r minus 2 pi r cube. All right. So s here is a constant. They have told you this given surface area. So s is constant. So dv upon dv r equals to half. Differentiation of this is s minus 6 pi r square. This thing is clear.
Yes, sir.
Now dv by dr equals to 0. This implies half s minus 6 pi r square equals to 0. So 6 pi r square equals to s, r square equals to s upon 6 pi and r equals to under root s upon 6 pi. Now we have to find if this is maximum or minimum. So dv by dr, we have to find d square v upon dr square, which will be equal to half differentiation of s will be 0 minus 12 pi r. All right. So we can see d square v upon dr square at r equals to s upon 6 pi under root equals to half into minus 12 pi into under root s upon 6 pi. So this thing is always positive, pi is always positive, 12 is always positive, half is always positive. So this whole thing is always negative, less than 0. So we can say at r equals to under root s upon 2 pi, v is maximum. All right. So if r is this, you can find the value of h. H is, let's see, h is s minus 2 pi r square upon 2 pi r. So s minus 2 pi r square is s minus 2 pi, 6 pi upon 2 pi r is s minus 6 pi under root. So this pi is pi cancelled. This is 3. So finally what we get, s minus s by 3 upon 2 pi into under root s by 6 pi. So this is 2s by 3 into 2 pi into under root 6 pi upon under root s. So this 2 and 2 is cancelled, and this is under root s. And if you take this inside, so this will go as 9. So under root 6 pi upon 9. Everyone is clear about this or not? Or am I just solving it down? Is everyone clear what I did here?
Sir, how did 9 come in the last part?
Right. See, this 3, if I have to put in under root, so I have to write under root 9, right, Krishna?
Yes, sir.
So I'm taking this 3 inside 6 pi. So this is whole under root. All right.
Okay, sir. Yes, sir.
So under root s, we can cancel this out. So 2 pi upon 3 under root. So now you can write this down as 2s pi upon 3 and under root. So this is h. Now what are they saying in the question? What is the relation between r and h? Let me get the question from here. Did you guys write down the question?
Yes, sir. Yeah, we should show whether height is equal to diameter of the base.
Diameter. All right. So diameter is 2r. So diameter is 2r and 2 and 2. I guess we did something wrong. We're not getting the value. What did we have as r? R is s upon 6 pi under root. Did we do any mistakes? Did I write this equation right? Everyone? I'm writing from memory. S minus 2 pi r square upon 2 pi r. S minus 2 pi r square upon 2 pi r. Yes. What is the value of r? R is s upon 6 pi. S upon 6 pi 3 2s by 3. Right, this is correct. Guys, note it down. All right, just tell me when I did a mistake. All right, because we are going to take a lot of time if I go through this all again. All right, Krishna, Ronaldo,
Yes, sir.
just go through it, write it down, and check whether the mistake is there, where the mistake is, and tell me. All right, because I have to go through and back. A lot of time will be consumed. Ronaldo, this thing is clear. Kulsum, Ronaldo, Ishan, Shikani. All right. Kulsum, we have not spoken since a lot of time.
I do understand, sir.
This thing is clear.
Yes, sir.
All right. Note it down. Tell me where I did the mistake. Let me also go through this. Till now, everything is correct. All right. Tell me when you have noted down this. Then we'll scroll down. Done till now.
Done, sir.
All right. All right, Shikani. We solved another question. Or we got, I think, the correct answer. No mistakes still here. This thing is also correct. Let's try to do this. I think this will be a simpler thing. We can write S from here. S is R square, 6 pi R square. Yes, S is 6 pi R square. Just put S, the value of S, 6 pi R square minus 2 pi R square upon 2 pi R. So 4 pi R square upon 2 pi R. Yes, this is very simple. So from here we can write H equals to 2R. All right. I think I did some mistake here. You can check this down. All right, everyone.
Yes, sir.
Please, you don't have to solve by this, but if you want, try to do that and tell me when I did the mistake. Otherwise, this is very simple. Just put the value of S, get the answer. Right. Note it down. Note it. I'm just pulling it down. Done, everyone?
Just a minute. Sir.
Don't tell me when where is the mistake. Done, everyone?
Done, sir.
All right, next question. Prove that the volume of the largest cone that can be inscribed in a sphere of radius r is 8 upon 27 of the volume of the sphere. All right, note it down. Tell me when you are done.
Done, sir.
All right. So in this question, they are saying proof that first of all, everyone remembers the formula for volume of a cone. Any warriors?
Sir, I think it's 1/3 pi r square h.
Yes, absolutely right. So this is a sphere. They are saying there is a volume in it. Sorry, there is a cone in with the maximum volume possible. All right. So this is the height of the cone. Suppose this is the center of the circle. Let's join this. This will be r. This will be r. Let's say this is x. All right. And the base of the cone, this is also small r. Everyone clear about this?
Yes, sir.
All right. So volume of the cone is 1/3 pi r square h. All right. So we have to write, remember this is small r, right? Don't take capital R. Capital R is the radius of the circle or the sphere. Small r is the base, radius of the base of the cone. All right. So again, we have two variables. We have to convert one into another. So how to find the variable? Can anybody tell me how we can find any equation involving r and h, small r and h?
Sir, what is x there?
X, this from center to the base.
Okay,
Right?
sir.
We don't know the length. See here, h is r plus x. So you can write v equals to 1/3 pi r square r plus x. Now we have two variable r square and s. So from this triangle we can use Pythagoras theorem. We can write r square, capital R square is small r square plus x square. Yes or no?
Yes, sir.
So now you can easily find r square equals to capital R square minus x square. Why did I choose r square? Because we have already r square in this equation. If we find x, then we will go into under root. We don't like under root, right? So v is 1/3 pi r square minus x square into r plus x. We have to differentiate this. Now please try to solve this by yourself. I'll give you a few minutes. This is very simple differentiation. Differentiate first, find the value of x, differentiate again, find if it's minima or minima, then find volume of sphere, divide, get the ratio. This thing is clear, everyone?
Yes, sir.
All right, Kulsum, Ronaldo, Ishan, Shikani.
Yes, sir.
All right.
Done, sir.
What about everyone else? Ronaldo, Krishna, Ishan, Shikani? Solving it?
Yes, sir.
All right.
So can you solve? I'm not able to find the solution as I'm stuck somewhere.
Okay, let's see. So Krishna, how much have you solved it?
So I was not able to get the root of it, like when I equate it with 0.
All right, let's see. So dv by dx pi by 3. Let's take it out. outside the bracket. So you can use product rule again. So this is r plus x into differentiation of r square minus x square plus r square minus x square into differentiation of r plus x. Right, Krishna?
Yes, sir.
dv by dx pi by 3 r plus x. What is the differentiation of r square minus x square?
Minus 2x.
Minus 2 plus r square minus x square. What is the differentiation of r plus x?
1.
1. So dv by dx equals to pi by 3. This is minus 2x into r plus x plus, you can break it down, r plus x into r minus x, so that we can take out something common. So let's take r plus x common. So this becomes pi by 3 r plus x minus 2x and plus r minus x. Right, Krishna? This is clear.
Yes, sir.
Now we have to put this equals to 0. So pi by 3 we can throw out. So finally we get r plus x into r minus 3x equals to 0. So from this equation we get r equals to minus x, and from this we get r equals to 3x. So x equals to r by 3 and x equals to minus r. So we have to disregard this. X cannot be negative. So we have to take x is r by 3. This thing is clear.
Yes, sir.
All right. Now d square b upon dx square. D square b upon dx square. Let's see. We got this is, let me rewrite this. dv by dx is pi by 3 into r plus x into r minus 3x. So pi by 3 r plus x into differentiation of this is minus 3 plus r minus 3x. All right, I differentiated directly. Now d square b on dx square, let's simplify this. Pi by 3 minus 3r minus 3x plus r minus 3x. So pi by 3 minus 2r minus 6x. So we can easily see, if you put x equals to r by 3 here, d square b upon dx square at x equals to r by 3, this thing will become negative, right? This is minus 2r minus 2r minus 4r. So minus 4r pi by 3. Right, Krishna?
Yes, sir.
So we can see this is less than 0. So at x equals to r by 3, v is maximum. So let's just find out the value. So please put the value in the previous equations, or tell me the equation. I'll solve all the way. All right, everyone, this is clear.
Yes, sir.
All right, Shikhani, Ishan, Ronaldo. All right, please note it down. I'll give you a few minutes to note it down. Done, everyone?
Done, sir.
All right. Everyone understood this question, right? Ronaldo, Ishan, Shikani. All right. Let's see. This is not the end of the question. You have to find the volume of both of the quantities, both of the shapes, and solve. All right. Next question. Just give me a second. All right. Show that the altitude of the right circular cone of maximum volume that can be inscribed in a sphere of radius r is 4r by 3. All right. Please try to solve this question by yourself. Exactly similar question. This is a sphere, this is a cone, and the radius of the sphere here given is small r. Assume this base radius is r. Draw a height. This is also small r. This is x. All right. Same way. Please try to solve this. You just have to find the value of h here. Everyone is clear about this?
Yes, sir.
Yes, sir.
All right. I'll give you a few minutes. Try to solve this.
Done, sir.
All right. Everyone else solving it?
Yes, sir.
All right. Tell me when you are done.